Hello, this video is on balancing equations. It gives us a brief introduction into subscripts, coefficients, law of conservation of mass, and then we'll actually see some examples and add coefficients in order to balance them. Now, before we get too in-depth, let me give you a general example. Anytime you go shopping, there's a price for the object. You have to pay that price in order to get the object. So, for example, if you are going around, you're buying a pair of shoes, let's say a nice pair of sneakers, and they are $80. Then you need to have exactly $80 in your wallet in order to pay for those shoes. You wouldn't want $20 because they aren't going to give you those shoes for just $20. You also wouldn't want to pay them $120 because that's too much. Otherwise, you'd be losing money. So, let's say we're buying a pair of shoes that's $80, and unfortunately, you only have $20 in your wallet. That's not going to work. So, you need to go to your bank. You need to pull out some more money. If your bank only gives you $20 bills, well, how can we get just $20 to be $80? If we have 4 of our $20 bills, so your bank hands you a $20 bill, and then another $20 bill, and then another $20 bill, and another $20 bill. If we go to our bank, we pull out 4 $20 bills, then we can get to our 80. 20, 40, 60, $80. This 4 is representing a coefficient, and we'll talk about coefficients later in this video, but it's the amount of $20 bills that we have. We are multiplying our 4 by the amount that our bill was. So let's refer to some chemistry stuff. The starting amount that you have are called reactants. And they form products. In a chemistry equation, we have to obey the law of conservation of matter, which means that the amount of your reactants has to equal the amount of your products. Otherwise, it's saying that we're just destroying matter. We're creating it out of nowhere. We can't just have $60 come out of nowhere. We had to pull it out of our bank. We had to pull, well, $60 more dollars is what I mean. We can't have $80 just come out of nowhere. We had to get it from somewhere. So it shows up in our equation. Now, law of conservation of mass. Matter cannot be created or destroyed. Your reactant atoms are simply rearranged in order to form new products. So, for example, if we were doing this random example, A is bonded to two B atoms, and then we're adding C to it. And then, so these are our reactants, we are forming AC, so now A is bonded to C, and then our 2 B's are left on their own. A reaction might look like this, where we have our A bonded to 2 of our B's, we're adding some C to it. Now, in order for A to now be bonded to C as a product over here to form our product, we're going to have to break these bonds. We're going to have to move A and C closer together so that we can form a new bond between A and C. And then these bonds that we broke apart, they will have to form a new bond to put the 2 B's together. So when we look at chemical reactions, we're looking a lot at how we are rearranging the atoms to form our new products. Some helpful hints to get into actual balancing. First, in order to see if it's balanced, we have to count the atoms on both sides. If you don't know how to do that, I do have a video titled CRHS McIrvin Counting Atoms. It goes in depth as to how we count atoms. Just a quick brief thing, if you see something in parentheses with a subscript on the outside, the subscript carries into everything in the parentheses. So in this case, we'd have 1 aluminum, 3 nitrogens, and 9 oxygens. If you need more help on that, again, here's another video as a reference. We add coefficients in front of our formulas when we need to increase the amount of our atoms. We can only ever increase the amount of our atoms. We can't ever decrease our amount. Coefficients and subscripts are multiplied together when we're counting atoms. Coefficients, because they're in front of the formula, they're going to apply to everything in the formula. We'll see some examples of that in a little bit. And then just as a little hint to kind of help you get started, if you see elements that show up in multiple reactants and or multiple products, save them until the end in order to balance. It would look something like this. C6H12O6 plus O2 goes to CO2 and H2O. Notice our oxygens show up 2 different places on the left side, 2 different places on the right side. That's going to be a lot harder to balance. So let's save elements that do that until the very end. Most often it's going to be hydrogen and oxygen. Okay. Now, before we get into some actual examples, let's see the difference between subscripts and coefficients. If I have H2O versus 2 H2SO4, these little numbers here in the bottom right corner, those are my subscripts. Now, your subscripts indicate the number of atoms for the element in a molecule. So in this case, because the 2 comes after the hydrogen, we're going to say that I have 2 hydrogens. I don't have a subscript after S, so I'm going to say I have 1. And this 4 comes after the oxygen, so I have 4 oxygens. Now, this number is in front here, 2 H2SO4. This is our coefficient. And our coefficient indicates the number of molecules we have of our compound. So this 2 H2SO4 is like saying we have 2 molecules of H2SO4. Or, if this is 1 molecule of H2SO4, then we have 2 molecules of H2SO4. So we can write it twice. If I go back and I try to count the atoms in here, from an earlier one of our points, we said that our coefficients and our subscripts multiply together to count our atoms. So this is 2 times 2 hydrogens gives me 4. 2 times the 1 sulfur gives me 2 sulfurs. Again, they multiply. So 2 times 4 gives me 8 oxygens. If you're more of a visual person and you like to write it out, again, it's like saying we have 2 molecules of H2SO4. We have 2 clumps. We have 2 of these $20 bills. In this one, we've got 4, and in this one, we've got 4. So together, we have 1, 2, 3, 4, 5, 6, 7, 8 oxygen. All right, let's see some examples. So first, I've drawn this line to kind of help separate our reactants from our product side. Let's go through and count our atoms. I don't have any subscripts, so I have just the 1 magnesium. And on this left side, I don't have any subscripts, so I have just the 1 oxygen. Over here on the right side, there's just the 1 magnesium. Over here, this subscript 2 gives me 2 oxygen. In order to balance this, I need the same amount of atoms on the left side as I do on the right side. Right now, my oxygens are not the same number. So what I have to do is I have to add a coefficient that can multiply by this formula in order to give me, in this case, 2 oxygens. So I've got 1 oxygen now. If I multiply it by 2, that gives me 2 magnesiums, because again, your coefficients apply to everything in the formula, and 2 oxygens. Great. Now our oxygens are balanced, but our magnesiums are not. So over here, I need to put 2 magnesiums in order to balance the 2 that are on this side. That's the general overall for some balancing. So let's try a couple more examples. Al plus O2, again, here's my borderline between my reactants and my products, need the same amount. I've only got 1 aluminum. Because of this subscript, I have 2 oxygens. Over on this side, I have 2 aluminums and I have 3 oxygens. Doesn't matter which one we start with. It's kind of, balancing is all kind of a trial and error. So if you start and you get stuck, erase it and try a different one. Or you can always keep editing it. The numbers you put as coefficients are never set in stone until it's finally balanced. So I'm just going to start with the first element. Here's aluminum 2. So let me put a coefficient in front of this aluminum. That would now give me 2 aluminum. Here, I've got 2 oxygens and 3 oxygens. All right, I'm trying to get those numbers to be the exact same thing. So, one way to think about this is what number does 2 and 3 both go into? Hopefully you said 6. 2 can go into 6 and 3 can go into 6. So let's try to get these oxygens to be 6 oxygens, because then they're the same number. All right, over here, if I want this to be 6 oxygens, I need 3 O2s, because again, 3 times 2 would give me 6 oxygens. Over here, these 3 oxygens, if I multiply it by 2, then 2 times 3 gives me 6 oxygens. Oh, but wait, that changed my aluminum. So now my aluminums aren't balanced anymore. So 2 times 2 instead gives me 4 aluminums. All right, that means that over here, this doesn't need to be a 2, it instead needs to be a 4. All right, double check. 4 aluminums. 2 times 2 is 4 aluminum. 3 times 2 is 6 oxygens. 2 times 3, 6 oxygens. Perfect. If you want to try these next couple examples on your own, I've kind of started adding up the atoms. But here's the next couple. Pause the video, try them on your own, and then I'll go through them. All right, welcome back. Hopefully you had a chance to look at these. This first one, BaCl2, and H2SO4 goes to BaSO4 and HCl. A couple things I want to point out. First, we have this SO4, which is a polyatomic. It's sulfate. Also notice that it shows up again as SO4 over here. So when I'm counting my atoms, I could count the sulfurs, and then I could count the oxygens. Or I could keep this as a clump, a polyatomic clump together, and just do SO4 as one thing, and SO4 as one thing. That might save you some time if you see a bunch of those polyatomics that show up on both sides. You don't have to write it every single time. If you can just look at it and figure out the coefficients, that's great. So let's try that with this one. I've only got 1 barium over here, 1 barium over here. I have 2 chlorines. I only have 1 chlorine over here. I've got 2 hydrogens. I only have 1 hydrogen over here. And I have 1 SO4 and 1 SO4. Or again, you could look at it as 1 sulfur, 4 oxygens, 4 oxygens. Now, it's my hydrogen and chlorines that aren't balanced. I've got 2 over here, only 1 over here. So I'm going to put a coefficient of 2. That's all it takes to balance these. All of these other coefficients, we can put a 1 in there. You can also just leave them blank. That's fine. Now, here, sometimes it's easier to split up your counting atoms, like sodium is here under sodium, and then I'm going to count the atoms over here on this formula. Notice hydrogen shows up in 2 different locations on the right side, so I've got a hydrogen here and a hydrogen here. I could put them all together and put a 3 here and not even worry about rewriting that. Sometimes it helps to keep them separate. Another technique if you're having trouble with this. So, it looks like it's just our hydrogens that aren't balanced. I've got 2 over here and 3 total on my right side. I've only got 2 over here on my left side. In order to get those to an equal amount, well, this hydrogen right here is what's making this an odd number. So if I make this an even number of hydrogens, then it would match the even number of hydrogens over here. So I'm going to put a 2 in front. That would change my sodium to 2, my oxygen to 2, and now my hydrogen over here to 2. Well, that gives me 2 hydrogens here, so that would give me 4 hydrogens total. I'm going to add the 2 hydrogens together to give me 4 hydrogens total. Well, to get these hydrogens over here to be 4, we multiply it by 2. 2 times 2 gives me 4. 2 times the 1 gives me 2 oxygens. Okay, now my hydrogens are balanced, my oxygens are balanced. All I need to do to balance sodium is make that a 2. So now I have 2 sodiums with these 2 sodiums. Perfect. Next example. 1 carbon, 1 oxygen. Here I've got 2 oxygens. Then 1 carbon and 2 oxygens. Okay, same idea as before. It's our oxygens that aren't balanced. I've got 2 on the right side and 3 on the left side. All right, this is an odd number, so let's make that an even number by multiplying it by 2. That gives me 2 carbons and 2 oxygens. Well, that messed up my carbons, and now I'm not quite on the right number with my oxygens. I've got 1, 2, 3, 4 over here and only 2 over here. So let me double this part, multiply it by 2. That gives me 2 carbons and 2 times 2, 4 oxygens. Let's double check that everything's balanced. 2 carbons, 2 carbons, 2, and another 2 gives me 4 oxygens, and I have 2 times 2 gives me 4 oxygens. Perfect. 1 nitrogen, 2 oxygens, 2 hydrogens, 1 oxygen, 1 hydrogen, 1 nitrogen, 3 oxygens, 1 nitrogen, 1 oxygen. Again, my oxygens and my nitrogens show up in 2 different compounds. I've kind of separated them. You can just write them all together if that's easier for you to look at. So, let's see. Oxygen shows up a lot. I'm going to save that until the end. I've got nitrogen and hydrogen. They only show up in, well, nitrogen over here shows up in 2 different locations. Not too bad, so I could probably start with anything. Let's save oxygen until the end. So, my 1 nitrogen here, to balance this one and this one, I'm going to double that. So let's say 2 nitrogens here. That gives me 2 nitrogens, and 2 times 2 is 4 oxygens. Now my nitrogens are balanced. Let's try to do the same thing for hydrogen. I've got 2 hydrogens over here, so I've got 2 hydrogens over here. That gives me 2 hydrogens. Oh, but look, adding that 2 changed my nitrogen. Now I have 2 nitrogens here and the 1 nitrogen here still. That gives me a total of 1, 2, 3 nitrogens. Let's check our oxygens. I've got 4 oxygens, 5. Then I've got 6 oxygens, and another one gives me 7. All right. Let's see. Because that changed my nitrogen, let's go back and change these nitrogens. So that gave me 2, 3 nitrogens. So instead of 2 here, let's try a 3. That gives me 3 nitrogens, and 3 times 2 is 6 oxygens. That 1 gives me 7 oxygens. Here, I've got 3 times 2 gives me 6 oxygens. Hey, look, this 1 leftover oxygen gives me 7 oxygens. So, I might be balanced. Let's double check everything. 3 nitrogens. Here's 2. And our third one. 6, 7 oxygens. 2 times 3 is 6. 7 oxygens. Got 2 hydrogens. Here I've got 2 hydrogens. And I've already balanced oxygen. So that's everything. Perfect. This last one here is a challenge. Pretty hard. This was on the level 3 of the PhET simulation. Go ahead and try this if you haven't had a chance to look at it yet. Okay, let's see how you did. Thinking through this. 1 nitrogen over here. I've got 2, 3 total oxygens. I've only got 2 over here. I've got 2 hydrogens, and I've got 3 over here. So, nitrogen's balanced, oxygen shows up in multiple places. I think I'm going to start with hydrogen. To get these 2 and these 3s to be the same number, let's multiply this by 2 and this by 3. That gives me 6 hydrogens, and 3 times 1 is 3 oxygens. That'll give me 2 nitrogens, and 2 times 3 gives me 6 hydrogens. All right, that kind of messed up my nitrogen, so now I have 2 nitrogens. Let's come over here and fix my nitrogens by putting a 2. That gives me 2 nitrogens, and 2 times 2 is 4 oxygens. Okay, so far my nitrogen and my hydrogen are balanced, but not my oxygen. So 2 times 2 is 4, plus my other 3 gives me 7. My oxygens over here come in a pair. I can only get doubled. I can only get an even amount from here. So, because I need 7 oxygens, let's try this. Let me put a 7 here, and then I'm going to double everything else. So instead of 2, I'm going to make this a 4. Instead of 3, I'm going to make this a 6. Instead of 2, I'm going to make this a 4. One technique when you have your oxygens, especially when you have O2, is to put that number as the number of your coefficients, because we're trying to get to 7 oxygens, so let's put 7 here, times 2. And because this is times 2, let's double everything else. Let's go back and check. Now, my nitrogens, 4 times N is now 4. 4 times 2 is 8 oxygens there. 6 times 2 is 12 hydrogens, and 6 times 1 gives me 6 oxygens. All right, 4 times N is 4 nitrogens. 4 times 3 is 12 hydrogens, and 7 times 2 gives me 14 oxygens. So let's compare. On this side, I have 4 nitrogens. On this side, I have 4 nitrogens. On this side, let's do hydrogen next. I have 12 hydrogens. On this side, I have 12 hydrogens. On this side, I have 8, and 6 more gives me 14. I'm going to add those two together. And on this side, I have 7 times 2 is 14. So we're balanced if we had doubled everything and then put our 7 here. So 4 to 6 to 4 to 7. I hope that was helpful. And keep practicing for balancing. It's going to be really hard. I can sit here and explain example after example and example, but you won't get it until you sit down and practice and practice and practice and try it out on your own. So go out. There's a whole bunch of practice examples on the website if you just want to Google balancing worksheets with answer keys. Practice it from there. Or we saw a bunch of examples in class. Those are a great place to start as well. Hope that was helpful, and I hope you have a great rest of your day.